Hello everybody. I'm going to solve problem 5.3 from Intellectual Electrodynamics, Griffith. So we have, the first question is asking us to find uh, uh, what is the speed of the particle in terms of electric field and magnetic field when we have no deflection. Well, let's imagine we have the particles coming at us. So I'm just going to draw a circle in the dotted center to say that the particles are coming toward us. So there's the direction, coming toward us. And then we know that we have an electric field and a magnetic field. These two have to point in opposite direction, of course, because they have to cancel each other, and they have to have the same magnitude. So I'm going to say that the electric field is going to be pointing down. This is completely arbitrary. It doesn't have to be. It can be pointing up, it can be pointing right, but I'm just going to make it point down. So this is going to be the electric force, Fe, and it's also the direction of the electric field, right? Then I have to find in what direction does the magnetic force has to be in order to counteract this. Well, it has to be in the upper direction, the opposite direction, with the same magnitude. So Fb. But in what direction does the actual magnetic field will be? Well, it's going to be in this direction, so towards the right. You can check this by actually using the right hand rule. Um, and it is pretty easy to solve, so I'm not even gonna I'm not actually gonna solve it much more. If you want, you can point the thumb in the direction of the force, and then the index in the direction of the stream of electrons, and then you have the direction of the magnetic field. As you can see, it's gonna be towards the right. Okay, so now we know that the magnitude of the magnetic force and the electric force have to be the same. Well, the magnetic force is going to be equals to the charge of the particle times the velocity across the magnetic field. Now we know that these two are perpendicular to each other. Therefore, the cross product will be the exact same thing as V times B. Okay, because they are perpendicular to each other. Now, this is actually not the dot product. Let me just make it clear. It's just the product of the scalar. So I'm just going to write like this, because we're trying to find the magnitude of this magnetic force. Instead, the electric force is a little bit easier, is simply Q times E. And of course, we have to find the magnitude of this. So we're going to simply, let me just do this. Okay, so we're going to simply put these two equals to each other. So I'm going to have this, oops, actually duplicate it, equals to this. I can get rid of the magnitude, of course, because we know it's going to be magnitude. And okay, so now we can cancel out the Q on both sides, of course, because we're on both sides. And we know that V is equals to, of course, we're always talking about the magnitude of this vector. Magnitude of V is equals to the magnitude of E divided by B. And that is a solution to the first part A. Instead, for part B, we have the radius, and we have to find the radius curvature, and we have to find what is the radius curvature in terms of electric field and magnetic field when we have the electric field to be zero. So when we have electric field to be zero, our force given by the electric field is equals to zero, of course. So now the only force that we have is our magnetic force that we said the magnitude is equals to Q V times B. Now this force is actually what is attracting our electrons towards the center of this curvature. So if we have electrons going this way and they start curving, the force that attracts it, I need to make a better curve. And the force that attracts it towards this point is our magnetic field force, magnetic force. And we also know that this is the centripetal force. And the centripetal force is equals to mv squared over r. So these two things are the same thing in our case. So we're talking about absolute values. So we're going to have Fp is equals to Fc. Centripetal force is equals to magnetic force. Let me just copy it and paste it. Here we would have the absolute value as well. So we can cancel all the absolute values because there's a solution to that. Okay, and then we can start canceling out our V. So let me do it in blue so it's a little more clear. V here. And we have to find it in terms of Q over M. Therefore, the what we have left is equals to V over RB. But we don't have to find it in terms of V. We have to find it in terms of electric field, the magnetic field, and radius. So if we go back and we use the result from the previous answer, we know that V is equals to E over B. So we can substitute it. And so we're going to have E over B times 1 over RB, which is then equals to E over RB squared. And that is the final answer to the second question. So these two are the two answers to the two parts of the level.